But before I do that, I'm going to show you a demo that's proven to be effective. This demo is called the shooter-dropper demo. Now suppose Greg the Mighty Hunter is out in one of the Great Lakes, and I'm just at the edge, so I'm up to my knees in water. And suppose I'm coordinated enough to hold my rifle perfectly horizontal. And let's suppose that Greg's also coordinated enough to hold a second bullet in his fingers while he's pulling the trigger. Now let's suppose that he's coordinated enough to pull the trigger and drop the second bullet at exactly the same time. Now the one bullet is just going to drop straight down, splash. The bullet that's fired is going to go out horizontal. Eventually it's going to arc down, hit the water, splash. The question is, which of those bullets is going to splash first, or do they splash together? Now, to answer that question, I have this gun. It's the closest they'll give me to a rifle, which is a good thing. I mean, if you guys, I'm not so worried about me carrying, I wouldn't, but if you guys could pack, what does that mean for me right after I turn back exams? I got one semester in me. Okay, now this thing fires bullets perfectly horizontal. Just missed your leg by that much. You could have owned this university. Now, this gun just works on a spring. It launches the bullet forward. Now, here's the neat thing. When it launches this one silver bullet forward, the plunger is going to pull itself out of the gold bullet and release it so that it can go straight down. Now what I want you to do is listen carefully and see if you hear one thunk or two thunks, whether you hear thunk or thunk thunk. One thunk, could have thunk it. Okay? Now folks, this is the big good news. Those two bullets landed exactly the same time because nature treats the horizontal motion completely separate from the vertical motion. They're completely independent of each other. Now both of these bullets had the same initial vertical velocity. They both were not moving up or down when they started. And that means that they dropped at the same rate and landed at the same time. Now, it turns out that the horizontal motion is completely left alone by nature. Whatever you have in the horizontal direction, nature just lets you keep it if we ignore air resistance, and we will. In the vertical direction, nature takes whatever you hand it, and every second adds 9.8, let's call it 10 meters per second down. Okay? So, the fact that these two motions are independent of each other allows me to make these complicated projectile motion problems trivial. Let me explain. If I look at the motion of that orange ball, it follows this parabolic path. And as it follows that path, it speeds up. So that means my velocity vector not only changes length, it also changes direction. That's messy. I don't want to mess with that. I certainly don't want to mess with that the Monday before the exam. However, if I break up that motion the way nature breaks up that motion, if when I fire that orange ball horizontally, I also bring in my friend, the blue ball, and drop it straight down. And then I bring in my other friend, the Energizer Bunny. You may be too young to remember this, but there were commercials where the Energizer Bunny would just go at a constant speed and never stop and never stop. And that's what we watched during the Super Bowl. You know, there was no fancy commercials, just an Energizer Bunny. We were easily amused. Now, here's the thing. The motion of that orange ball is the combination of the horizontal motion of the bunny and the vertical motion of the blue ball. Watch. If I wait for a certain interval of time, this velocity vector here has an x part equal to the Energizer Bunny's velocity. That would be this velocity right there, the x part. And the y part of its velocity is equal to the velocity of the ball that was dropped. A little time later, the x part of this vector here is still the same as it was at the beginning, Energizer Bunny. But the y part of this velocity, the downward part, is equal to the velocity of that ball that was dropped. A short time later, the x part is still exactly what it has always been, and the y part of that velocity is the velocity of the ball that was dropped. And then we hit the bunny rabbit, and there's the bunny rabbit. Oh, he's fine, people. I just found a picture of a bunny that was sleeping. Some guy was proud that his buddy could sleep. I mean, a lot of bunnies sleep. Okay, he's fine.